Example number 2, we're on the back side of 1.4 notes. There are a need here to write a piecewise function. We're doing a little bit of combination of both Algebra 1 and Algebra 2 class because I need to write out equations of the lines, but I also want to focus on the intervals. So let's go ahead and do a little bit of work prior to the actual writing out of the scenario here. I think highlighting things is certainly a good thing. As this travels left to right, it is going upwards. I do see the arrow that is pointing down, but as we read left to right, that line is traveling up. We know the arrow is pointing left. Now it's also pointing down, but if I'm talking about intervals, I'm not really worried too much about that. If I take a look at the second piece here is going down. It's going down from left to right. If I read left to right, that is going down. I do see that arrow right there pointing to the right. I also want to make special note here that I have a included point right there and an excluded point right there. We're going to need that in this situation as well. Let's go ahead and first focus on the intervals. For the green one, the first one up as I'm reading left to right, I see the left highlighted, the arrow pointing to the left, so we know in terms of x values that means there's a negative infinity. Never going to quite get there, so the arrow doesn't have a line underneath it. The stopping location for that interval looks like it's at an x value of -2, and it's included, so it gets the line underneath it. That is the first interval. Intervals, of course, having a conversation only about the x values. The second interval starts at -2, but as we said before, it is an excluded point, so it does not get a line underneath that arrow. I see the arrow pointing to the right in red. Since it's going to the right, it means that it's traveling all the way to positive infinity. We know we never quite get to infinity, so the arrow doesn't get a line underneath it. We have taken care of the intervals. This piecewise function, there's 2 pieces. Now we got to go ahead and make the equation of a line. I'm going to do a little bit of erasing just so that we can be able to dot some things out eventually. I would actually make an argument that the second one that was in red is actually a little bit easier to read, but we'll get there. All right, the one in green, let's go ahead and get the slope. Any 2 points on the line. Well, I'm going up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So up 1, right 1, that's, of course, a +1 slope. I'll go ahead and write out 1x for the slope. Now, this line gets cut off before it hits the y-intercept, but we have to kind of do a little bit of guessing here in terms of, not guessing, counting things out. If the pattern continues, up 1, right 1, up 1, right 1, it would eventually hit at -2. The y-intercept would be -2. I do want to include that in the equation of the line, even though, obviously, the interval is stopping. So I have the first piece taken care of. The second one, the one that is decreasing, is a little bit easier in terms of writing out. Let's go ahead and count out the slope. I go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. That pattern continues, down 1, right 1. The word down is a negative. The word right is a positive. Negative over a positive would make a -1x for our slope. Where does this hit the y-axis? Thank goodness we don't have to count this one out. It's already showing us that the y-intercept is right there. The y-intercept is -3. So again, I think that one was a little bit easier than the other one. So again, 2 pieces. We highlight it. We understand what the interval is telling us straight up. First, obviously, pinpoint the arrows, write out the intervals, and then the linear equation.